about R-naught, the basic reproductive number. This is probably the single most famous number in infectious disease epidemiology, and after the last few years, it's a number the general public has opinions about too. So let's make sure we're precise about what it actually means. R-naught is the average number of secondary cases generated by one infectious individual in a fully susceptible population with no interventions in place. Every part of that definition matters. Fully susceptible, nobody is immune, no interventions, meaning no vaccines, no isolation, no distancing. It's the raw theoretical epidemic potential of the pathogen, measured at the starting line before anything pushes back. Now the thresholds, which are beautifully simple. If R-naught is greater than 1, each case infects more than one new host and the epidemic grows. If it equals exactly 1, transmission is sustained but stable. That's your endemic steady state. The disease persists without exploding. And if it's less than 1, each case infects fewer than one new host. Chains of transmission die out and the outbreak fades on its own. So the goal of every single intervention you will ever design comes down to one sentence. Drive R below 1. That's it. Vaccination, isolation, movement restriction, treatment, every tool is pointed at that same target. And the formula tells you exactly how to get there. R-naught equals beta times kappa times D. Beta is the transmission probability per contact. You attack that with PPE, with treatment that lowers shedding, with disinfection and pathogen reduction. Kappa is the contact rate. You attack that with social distancing, movement restrictions, and quarantine. D is the duration of infectiousness. You attack that with early detection, rapid isolation, and antiviral therapy. The beauty of a multiplicative formula is that each factor is an independent lever. Cut any one of them in half, and you cut R-naught in half. And in a real response, you're actually pulling all three at once, which is why layered interventions work better than any single measure. Now look at the real-world values on the right, because they give you intuition. Measles is 12 to 18, extraordinarily transmissible, and that's why measles is always the first disease to come roaring back when vaccination coverage slips. Foot and mouth disease, 8 to 15, which is why an FMD incursion triggers such an aggressive response. Original COVID-19, 2 to 5. Influenza, 2 to 3. Ebola, 1.5 to 2.5. Which surprises people because Ebola is terrifying, but it's not especially transmissible. Severity and transmissibility are completely different axes. One last note, R-naught is a property of the pathogen and the population. Contact patterns, density, and behavior all feed into it. The same pathogen can have a different R-naught in a dense feedlot than on an extensive pasture. If this helped, like, share, and subscribe for more.